This is Mr. Naughton here. Howdy, we're going to go ahead and get started with our coordinate geometry day. So our goal here today is if I were to give you any 4 points, and I'll just plot them like this, and basically say, if I were to connect them, what shape is that? Okay, now it could be a trapezoid, could be a parallelogram, could be just a quad. How can we prove that for sure? So what is that? So we're going to go ahead and do this mathematically. And so we're going to use a couple of formulas that you know well. So some of the properties that we've talked about so far are parallelograms and squares and all that have congruent sides. So if that is the case, that means that they have the same distance. So that same distance would imply that I would use the distance formula of x2 minus x1 squared, and then y2 minus y1 squared, and then the square root of all of that. And then, ladies and gentlemen, we could talk about perpendicular, like diagonals are perpendicular. And that's where you're going to have opposite, reciprocal slope. An opposite reciprocal slope just means basically it's going to flip and they're going to have different signs. So that would mean I would need to use the slope equation, which is y2 minus y1 x2 minus x1. Now, if they're parallel, that means they're going to have the same slope. And the same slope would imply that they're literally the same number. So once again, I would use that same formula of y2 minus y1, x2 minus x1. And then, ladies and gentlemen, let's take a look at this really quickly. So if they're the same slope, that means literally one would be something like 1/2, and then the other one might be something like 2/4. But when I reduce that, we're still going to get the same thing of 1/2. So that's what we mean when we talk about the same slope. But when we talk about opposite reciprocal, that means one slope might be 1/2, but I'll say the slope perpendicular, that's going to be the flip. So it'd be 2/1 and be negative, or sometimes it just looks like -2. Okay, so that's a quick example. And then midpoint obviously is going to be our middle. And the way we're going to do that is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Alrighty, so if I were you, the ones I would use are the slope ones. Well, that's not my highlighter, but we'll circle it anyways. The slope is going to be really beneficial for us. Okay, so coordinate proof is going to go ahead and use formulas to prove a shape. So use formulas to prove a shape. Alrighty. So it says in our directions that we're going to prove that this KLM is a rhombus. So that means I have to use the distance formula to prove that. Okay. So remember, a rhombus means they have to have the same length or the same distance. I'm going to use distance today because we're going to be using the distance formula. So I'm going to plot all these 4 points right here. So I'm going to go 2, 5. So 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's K. And that's going to be 2, 5. And then L is -2, 3. So this is L at -2, 3. And then 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. That's N. And then M is 2, 1. So, ladies and gentlemen, if this is my shape right here, first off, it definitely looks like it is a rhombus, so that's a helpful hint. But what we need to prove is that this side is going to be the same as this side, is the same as this side, is the same as this side. So essentially, we would do the distance formula 4 times. So ladies and gentlemen, boys and girls, let's start with this side right here. So L, K. So L is -2, 3, and K is 2, 5. So you always move from left to right. So my left point is going to be x1, y1, and then x2, y2. So my distance formula, as we wrote above, is x2 minus x1 squared, y2 minus y1 squared, and then the square root of all that. So 2 minus a negative 2 squared plus, then 5 minus 3 squared is going to be a negative and a negative. Boom, boom, is going to make this a positive 4 squared, which is 16. And then this is going to be just minus, so this is 2 squared, which is 4. So when I add those together, I'm going to get square root of 20. And then do my factor tree. So 4 and 5, 2 and 2. Remember, we circle our pairs, so here's a pair. Broke down the 4 and the 20, so we cross those out. And so this is going to be 2 root 5. So that is the one length right there is 2 root 5. So we're going to prove that all those are also 2 root 5. Cool with that? Alrighty, so let's go and do our next one here. And that's going to be x1, y1, x2, y2. So 6 minus 2 squared plus 3 minus 5 squared. Take the square root of that. So 4 squared plus a negative 2 squared is going to be 16 plus 4, which is 20. And we already know what the square root of 20 is because we did it over here. So we know that this is also 2 root 5. Alrighty, so I'll erase my points here. So now we're going to go ahead and prove this one right here. So x1, y1, x2, y2. So this is going to be 6 minus 2 squared plus 3 minus 1 squared. So 4 squared plus 2 squared is going to be 16 plus 4, which is root 20. All right, and again, that's 2 root 5. We've already done that. So last but not least, we have this one, LM. So we'll go ahead and erase because we have new x1s and y1s here. So friends, this is going to be x1, y1, x2, y2. So 2 minus a negative 2 squared plus, and then 1 minus 3 squared. Take the square root of all that. That's 4 squared plus a negative 2 squared is going to be 16 plus 4, which is 20. Square root of 20, 2 root 5. So because we have all the same sides, they're all this, as we've already mentioned, that 2 root 5, then they are congruent. Okay, it is a rhombus. Now, here's another fun little trick, and I would zoom in for this. So if I go ahead and I'm drawing my diagonals here, because it's perpendicular, because that's what we know about rhombuses, we can use the Pythagorean theorem. So this is 2, and this is 4. This is 2, and this is 4. Each one of those you can do and make a right triangle. So if I had to just do this one right here, 2 squared, 4 squared is equal to x squared, which is what we're looking for. So 2 squared plus 4 squared, a little Pythagorean theorem action, is 4 plus 16. Oh my goodness, this is like deja vu. And then I would need to take the square root. Boom. So I'm going to go ahead and I'm going to amend these notes. So not only can you use the distance formula, but you can go ahead and also use a squared plus b squared equals c squared with your right triangles. Or I'm going to write my perpendicular sign right there. So add that to your toolkit, because that will be helpful. All right. If you need to go ahead and do that again, feel free to do it. Now, most of our examples are going to be this. I'm going to give you 4 points and say, what shape is it? So the first thing I want you to do, steps for success, is going to be to graph it. And then it's going to be to narrow it down. You're going to narrow it down to 2 or 3. And then you're going to go ahead and go from there. Step 3 is go ahead and prove. Okay? If it doesn't look like a trapezoid, it's not a trapezoid. Your eyes are super important. So I'm literally going to put use your eyes right here because that is your best helpful way to get started. All right, so I'm going to plot these right here. So D is 2, 2. And then C is 4, 1. And then B is 1, negative 1. And then I have -1, -4. 2, 3, 4. I did something wrong here, sports fans. Let's figure out where I did wrong. Because that doesn't look like any of those shapes. So, I'll try again. -1, -4. 1, 2, 3, 4. So that's A. And then 1, -1 would be right here. This is B. And then 2, -2. That's where I messed up here. 2, -2 would be this point right here. So this is B, this is D, and then 4, 1. 1, 2, 3, 4, 1. Alrighty, so if I were to connect these dots right here, what does that shape look like? Okay, kite, sure. I don't know why I did SH, but yeah, it could be a kite, sure. Could be a rhombus, sure. Could be a square and a trapezoid, don't think so. So we've narrowed it down to 2. That's that step 2, is narrow it down. So what's the difference between a kite and a rhombus? Well, the sides. So this is going to have 2 pairs of consecutive congruent sides, and this is going to have 4 congruent sides. So what I'm going to try to do is prove that there's 4 congruent sides. Now, to do this, I'm going to make some right triangles, because I said those right triangles are our friends. So right here, to find that side length right there, I'm going to make this right triangle. So if I count, this goes, oh, sorry guys, 1, 2, and this goes 1, 2, 3. So for that right triangle, I'm going to look for this side right there. I'm going to do 2 squared plus 3 squared is equal to x squared. So 4 plus 16 is 20. And then we know that we have to take the square root of that because we just got done doing that. So this is going to be 2 root 5. So the answer is, if it's a kite, if only 2 are 2 root 5. It's a rhombus, I'll just put rhomb, if all 4 are 2 root 5. So let's go ahead and take a look. So I'm going to make another right triangle here and down here. So 1, 2, 3, 1, 2. So again, I'm looking for this side length right here. But if I count, this is 1, 2, and this is 1, 2, 3. Well, that looks like the same thing. 2 squared plus 3 squared. And I'm going to call this just y squared. So 4 plus, oh, goodness gracious. There's some bad math. Sorry. That's a 9. This is what happens when you're going fast, right? So this would be 13, and it's just the square root of 13. So if they're all root 13, apologize there, at least we caught it, right? So 9, so that's also the square root of 13. So let's do this one right here in orange. So this is 2 and this is 3. We've already done that math, so we're probably pretty good there. And what about this one? Right triangle, 2, 3. So these are all 4 sides are going to be root 13. So this is going to be a rhombus. Cool with that? So that's basically what we're going to be doing, is using those 3 steps to really make this work. So we could let you do those kind of stuff all day long, okay? But sometimes it asks us to say, what is the 4th point? And so that's what this last example is. This is our last one, right? Oh, sorry. One more after this. Howdy, y'all. We're going to go ahead and do this example. Sorry, it's going to jump a little bit. I just botched this one, so we're going to hit the redo button. So on this one, it says, what is the 4th point that we're going to need to make it a parallelogram? The most important thing you can do is graph correctly, which is why I script the last one so bad. So let's try this again. So -3, 3. So 1, 2, 3. That's B at -3, 3. Then 3, 4. 1, 2, 3. 1, 2, 3, 4. That's C. And then 4, 1, 2, 3, 4, 1, 2. So that's D. So it's saying it's a parallelogram. So the shape is going to have to look something like this, because we can clearly see that's how it's orientated, right? So it means our answer should be somewhere down in that region. Now, we can use that as a process of elimination to get rid of some of our points. Now, let's go ahead and remember what a parallel line is. That's going to have 2, I don't know what that was, 2 sets of parallel sides. Parallel, again, means it's going to have the same slope. So you can do this whole y2 minus y1, x2 minus x1, definitely can. Or you can do rise over run, which I think we all like better. Now, rise is going to go ahead and become up or down, and then our run is always to the right. You good with that? So in this case, if I were to find this side, I'm going to go up 1, as we can see right here. Whoop, whoop, whoop. Up 1, and then I'm going to go over 1, 2, 3, 4, 5, 6. So my slope is going to be 1/6. So basically, I need to go ahead and basically do the opposite because I want to end here at D. But the idea is that I went up 1, right 6 to end here. So if I wanted to end there, to go backwards, I probably should do the opposite. So the opposite would be 1, 2, 3, 4, 5, 6, down 1 right here. And that's at the point -2, -3. So -2, -3 is going to be C. Alrighty, in our last example here, we want to go ahead and answer these questions. Okay, so is it an isosceles trapezoid? That means it's going to have congruent legs. And then it's going to say what are the coordinates for the mid-segment. So that's going to be our midpoint. And what is the length of our mid-segment? That's going to be the distance formula again. So we got lots to do on this last one. So let's go ahead and plot this. So I'm assuming that this is supposed to be an A there. So -3, 4. So 1, 2, 3, 1, 2, 3, 4. So that's A. And then I'm going to have -5, 2. So 1, 2, 3, 4, 5, -2. Oops. There we go. B. And then 5, 2. So 1, 2, 3, 4, 5, -2. C. And then we're going to have 3, 4. 1, 2, 3, 1, 2, 3, 4. So I'm going to say, is this an isosceles trapezoid? Well, it definitely looks like it. So how could we say for sure? Well, what I want to know is this length and this length. So if you want to use the distance formula, go for it. But I'm going to go ahead and make a right triangle again. And we're going to see that this is going to be 1, 2. And this is 1, 2, 3, 4, 5, 6. So to find that, it's going to be 2 squared plus 6 squared is equal to x squared. Again, why we did the Pythagorean Theorem at the beginning of this unit is now very clear. So that's root 40. So it's not asking for the distance, so I'm just going to leave it as that. Let's go ahead and see if I can't find the same on the other side, this one right here. So as we take a look, this is a 2, this is a 6. Those are the same values. So it's going to make sense that 2 squared plus 6 squared is equal to y squared. This is going to be 4 plus 36, which is the root 40, which because those match, boom, boom, then we can say that this is definitely a yes. So what are the mid segments? Okay, so the mid segments are going to be the midpoints. Now, let's be honest, you probably could look at this segment right here and this segment right here and decide what those mid segments are just by going ahead and I'm going to erase just so we can focus. I realize there's a lot going on here. So this segment right here, this segment right here, we could probably estimate what that is, right? Because we're looking for the middle, but let's use our formula. So A was -3, 4, and this was B, which was -5, -2. So it's x1 plus x2 divided by 2, y1 plus y2 divided by 2, and we go from left to right. So x1, y1, x2, y2. So it's going to be -3, -3 plus a -5 divided by 2, which is -8 divided by 2, which is -4. And then this is going to be -2 plus 4 divided by 2, which is 2 over 2, which is 1. So that's this mid-segment right here. So we can go ahead and assume that this is going to be one of those. And remember, there's going to be the midpoint. It's got to be parallel to the other side. So parallel, parallel, parallel. So if you draw that parallel across, you can find out that right here would be the other one, and that's going to be at 4, 1. Because again, the mid-segment is parallel to the basis. So we now know that this is going to be negative 4, 1, and then 4, 1. So what is the length of that? Well, if it's going at an angle, we'd have to do the distance formula. But because this is flat, again, this is flat, so you can go ahead and just count 1, 2, 3, 4, 5, 6, 7, 8. That's it. You're done. All right, guys. Hopefully that this helps a lot. We'll see you on the flip side. Take care. See you next time.